Welcome back. Here we are, ready to start our scanning phase. We have covered the information gathering, which was first phase of penetration testing, and now we will proceed with the second stage by scanning our target and trying to get even more information about it. Now, the difference between information gathering and scanning is that scanning is performed on a much deeper level. And also, while in the first phase we gathered all kinds of information such as emails, phone numbers and a bunch of other things, in the scanning we are mainly focused on technology side. So we want to find out as much as we can about our target's technical aspect. We're going to talk about in just a second as to what exactly are we looking for in this stage and what are all the goals of this stage. But first, you could be wondering, what are we going to scan? Since remember that scanning is something that we are not allowed to do on any target that we want. Don't worry, for this stage and any future stage from now on, we're going to be using vulnerable virtual machines. There are lots of paid vulnerable virtual machines that you can buy and test on, but for this course I will be showing the free ones. So all of us can download them, install them and then try to hack them. All of these virtual machines are going to be running some outdated vulnerable software that we will be able to exploit in the third stage, and they will also require very little hardware power. So all of us will be able to run them while also running Kali Linux. And keep in mind that penetration testing process will look exactly like it will look in real world, if you were to test some website or some network. The only difference is that right now we know that these machines are vulnerable since I just told you, and in real world you wouldn't essentially know that before testing them. However, just knowing they are vulnerable doesn't really help us, as we need to figure out in what way are they vulnerable and how can we take advantage of that. Scanning will help us with this. We will be using our Kali Linux machine to scan these machines. And by scanning these machines, what I really mean is we're going to directly exchange packets with our target, and once that target sends packets back to us, hopefully it will discover something about the target machine that we will find useful. And what we will be sending to the target are TCP and UDP packets. TCP and UDP are just protocols that are used for sending bits of data, also known as packets. And we will discuss them in a little more detail in the next video. For now, just think of them as different communication protocols that will allow us to get information from our target. I keep talking about information and scanning and all of that without actually explaining what do I mean by scanning and getting information. What are the goals of this? What are we looking for exactly? Well, we're looking for open ports. And I don't mean USB ports or some physical ports, I mean we're looking for virtual open ports that every machine has, and it uses them to host their software and communicate with other machines over internet. For example, you watching this over internet on a website means that the machine that's hosting this website has port 80 open. Why port 80? Well, port 80 is used to host a web server. It is used for HTTP, and it's also known as HTTP port. So every time you visit a website, you are essentially making a connection to that machine hosting that website on port 80 or on port 443, since port 80 is used for HTTP and port 443 is used for HTTPS. And HTTPS is just a secure version of HTTP. These are the two most usual ports that target that you're scanning externally will have open. And by externally scanning, I mean that you're scanning it while not being in the same network as the target. An example would be you scanning some website from your home. And a port that could sometimes be open if you're scanning internally, which means either scanning machines on your network or you're performing network penetration testing inside of some company, you could for example find port 21 to be open. This is an FTP port and it's used for file transferring. FTP stands for File Transfer Protocol. These are just two of the ports and there are a lot of them. you could, for example, have port 22 open, which is SSH port or secure shell port. It is used to log into the target machine and execute commands on it remotely. We could also have, for example, port 53 open, which is DNS port, or we could have port 25 open, which is SMTP port. So there are a lot of ports. Matter of fact, every machine has 65,535 ports for both TCP and UDP. And if there is just one open port with one vulnerable software running on that open port, then that target is vulnerable and it could be exploited. Now, the highest secured machines are the ones that have all ports closed. These are usually your home devices, such as laptops or computers that you use just for browsing online or playing video games or something. They don't need to be hosting any software since they are not a server that someone will connect to for a certain service. They're just home devices that you use. But websites, for example, must have port 80 or port 443 open since they are hosting a web page there. Also in companies, their machines could have some port open. Maybe they use that port on all their machines within that company to internally transfer files between different machines. It could be anything basically. Now, the problem occurs if that software they use on their open ports is outdated and has a vulnerability. Then our job as a hacker is to scan that machine for open ports and exploit that machine through that vulnerable software running on that open port. But the goal for now in the scanning section is only to scan the target for the open ports. Then we want to discover what software are they running on those open ports. And we want to go as deep as discovering what version of software is on that open port. Are you ready? We're going to be covering a lot in this section, and in this section we will cover one of the most important tools that a hacker must master. That tool is called Nmap. Let's dive into scanning. Welcome back. Before we proceed with scanning, I just want to give a basic overview of TCP and UDP protocol for anyone that is encountering it for the first time. We already mentioned what TCP and UDP are. They are two different protocols used for sending bits of data, or also known as packets. TCP and UDP are not the only protocols that are out there, however, they are the most widely used ones. Let's talk about TCP first. So TCP stands for Transmission Control Protocol, and it is the most commonly used protocol on the internet. When you load a web page, your computer is sending TCP packets to the web server address, asking it to send the web page to you. Then the web server responds by sending a stream of TCP packets, which your web browser stitches together to form the web page that you see. The same happens once you, for example, click on a link or sign in or post a comment. Your web browser sends TCP packets to the web server, and the server sends TCP packets back. However, TCP is not a one-way communication. The remote system sends packets back to acknowledge that it received your packets. So TCP is based on three-way handshake. And as the name says, three-way handshake is consisted out of 3 steps. First one is SYN. In this step, the client wants to establish a connection with the server, so it sends a segment with SYN, and what SYN stands for is Synchronize Sequence Number, which informs server that client wants to start communication and with what sequence number it starts the segments with. After the SYN step comes the SYN-ACK, which is the second step, and in this step the server responds to the client request with SYN-ACK signal bits set. ACK signifies the responsive segment it received, and SYN is the same from the first step. It signifies with what sequence number it is going to start these segments with. In the third and final step, which is just ACK, in this step the client acknowledges the responsive server and they both establish a reliable connection with which they will start the actual data transfer. This is just an example of TCP communication establishing between a client and a server. Once the data transfer starts, TCP guarantees the receiver will get the packets in order by numbering them. Then the server sends messages back to the sender saying it received the messages or packets. If the sender does not get the correct response, it will resend the packets to ensure the server got the packets. All of those packets are also checked for errors. So TCP is all about reliability. Packets sent with TCP are tracked so no data is lost or corrupted in transit. That's why once you download a file, for example over the internet, your file is working once you run it on your machine, because it is being transferred with TCP, so all of the packets will reach their destination without any errors. UDP, on the other hand, stands for User Datagram Protocol. A datagram is the same thing as a packet of information, and UDP protocol works similarly to TCP, but it throws all the error checking stuff out. That's why UDP is much faster. It is used when speed is desirable and error correction is not necessary. For example, UDP is frequently used for live broadcasts and online games. That's why UDP doesn't really care whether packets received its destination, and it will not resend the packet if it didn't reach the other part. It will just continue sending other packets. You cannot ask for those missing packets again with UDP, and these are just the basics behind two most known protocols for communication. Even though many of you probably knew this already, it is good to have a refresher since we're going to need this knowledge once performing scanning. See you in the next video. Okay, so we know what scanning is. We also created our virtual machine that is vulnerable, and now we are ready to see what information can we get by scanning that machine. But before we scan a single machine to discover open ports, we must first discover what machines we got on our network. So the first part of scanning a network is to figure out how many hosts you have active and what are their IP addresses. In this case, we are going to act as if we got a task to scan our home network. And we want to discover vulnerable machines within our home network. So let's start by seeing how many hosts we got active first. There are many ways that we can go about doing this. Since I know that all the possible hosts for my network must go in range from 192.168.1.1 to 192.168.1.255, since my IP address starts with these three first numbers, let me just type the password, and here it is, 192.168.1. This is the part that doesn't change. And to scan all 254 hosts inside of my network, I can just go and ping each and every one of them, and see whether they respond to our pinging or not. If they respond, they are online. If not, they are offline. But what if I had to test more than one network? What if I had 10 more networks, besides this one, that I needed to test? Am I about to try to ping every possible host from all those networks? Of course not. That's why we are going to use different tools to perform this much faster. Let us try with the first tool called ARP. Now, ARP is a tool in Cal Linux, but it is also a packet. ARP packets are used in discovering hosts on the network, but more about them later on once we get to the man in the middle section. For now, just remember that they are packets for discovering hosts. Before we use this ARP tool, make sure your Metasploitable is started up. And in case you got some other devices that you can connect to the internet, connect them just so we can get various output and try to figure out which IP address belongs to which host. Now, our ARP tool works based on those ARP packets that I mentioned. So if I type ARP --help and press enter, it will tell me command not found. Now this is because I must run the tool with sudo privileges. So sudo ARP --help, and here is the tool. It doesn't have too many options. We got -A, which displays all hosts in alternative BSD style, -E, display all hosts in default Linux style, and these options down here are not something that we're interested in. All we want to do is use this -A option. So if I go down here, clear the screen, and type sudo ARP -A, it will tell me it only discovered my router. But why is that? I got my Metasploitable running, also got my laptop running, so it should be discovering other hosts as well. Sometimes we must ping a host first before it appears right here, since this information is being read from our ARP tables. So if I, for example, try to ping my Metasploitable, it will get responses back, and if I run arp-a again, now we will see that we got an entry for the Metasploitable inside of our ARP tables. So this tool doesn't seem to be that good for discovering hosts. Sometimes it will have all the hosts available since you already communicated with them before, but sometimes it seems that we must ping the host first before it shows them. That's why a much better option is a tool called netdiscover. To run netdiscover, we can simply type sudo netdiscover inside of your terminal, press enter, and this tool will find all of the available devices on your network on its own. You don't have to ping anything, you don't have to communicate with anything, you can just leave this tool to run and it will find all the devices on your network. So right here it managed to find 5 of them. We can see up here that it is still scanning and it is just scanning different subnets, so it already finished mine, and you can Control-C this if you already see the result, since this will scan all the usual subnets that occur in a network. Right here we see that we captured 5 ARP packets, and there are ARP requests and ARP replies, but once again more about that later. This just means that we managed to discover 5 hosts using these packets, and these are those 5 hosts. Let me Control-C this, since it won't really manage to find any more hosts. And right here we got their IP addresses, their MAC addresses, and their MAC vendor name or host name. So right here, I know that this is my Metasploitable, which is this one. This 192.168.1.7 is my host machine or my physical machine that I'm running my Cal Linux on. These 2 down here are 2 laptops, I believe. And this right here is my router. And how do I know that this is my router? Well, usually routers start with the first number. Either it will be something like .0 or .1. And just so you can be sure which IP address is your router, you can type the command netstat-nr, and under this gateway column we should see the IP address of the router. So you can see they do match. The next step would be to go about scanning each and every one of them. And for this we're going to be scanning our Metasploitable, and you can also scan your home machines just for even more practice. See you in the next video. It is time to start with the first big tool that is essential for ethical hackers. That tool is called Nmap. We're going to cover a lot of things inside of it, and unlike all the other tools that we covered by now, which you might or might not use in penetration tests, this is a tool that you will almost always use without any doubt. So what is Nmap? Nmap is a network mapper. It is a free and open source network scanner, and it is used to discover hosts and services on a computer network by sending packets and analyzing responses. It has a lot of different options, and we're going to check them out in the next few videos. For now, let us just see how we can start Nmap and run a basic scan. First thing, make sure your Metasploitable is up and running, and also if you got any other devices in your home network, turn them on just so we can scan them as well. Okay, let us see how we can run Nmap and what options do we get with Nmap. Just like all the other tools, we can get the Nmap help menu by only specifying Nmap in terminal or specifying Nmap --help. And you will see right away we get a lot of options right here. And this right here is just a short help menu. We will see the longer menu once we start experimenting with these options right here. But for now, we're only interested in running Nmap with just a basic scan. So for basic scan, all we need to do is specify an IP address. If we go to the help menu and you scroll all the way to the top, we should see target specification right here. It tells us that we can provide a host name, an IP address, or a network for scanning. And below that we got some of the examples of what we can specify with Nmap and what is the syntax for specifying hosts. We can also read our targets from a list by specifying option -il. And if we want, we can exclude some hosts that we don't want to scan by specifying --exclude option. For the first time, let us get an IP address from our Metasploitable and let's scan it to see what results we get for scanning one IP address. We already saw how we can get Metasploitable IP address. You can either run netdiscover to see all the online hosts, or if you don't want to bother, you can just go to Metasploitable right here and type ifconfig. I can see that the IP address of my Metasploitable is 192.168.1.6, so that is the IP address that I will use. Let's run our first Nmap scan. If I type Nmap and just 192.168.1.6 and press enter, wow, this finished pretty fast. But don't get used to it. The only reason that this scan finished so fast is because the target is on my home network. True Nmap scans can sometimes take hours to finish, depending on where your target is, how many ports they have open, are they protected by firewall, and many other things that we are also going to cover. But for now, this is the response for our Metasploitable with our basic scan. So it tells us that host is up, it tells us which open ports it has, we get the exact number of which ports are open on the target machine, and right here we can notice that there are a lot of ports that are open. That is because Metasploitable is running a lot of services. Nmap also tells you, besides the port that is opened, which service is running on that open port, and this is this third column. So we can see that port 21 is open and it is running FTP, which we already know that it's file transfer protocol. We got port 22 to be open, and that port is for secure shell. We got port 80 that is opened, and that is an HTTP port, and this could mean that our Metasploitable could be hosting a web page. We can check this out if we type the IP address of our Metasploitable inside of our Firefox. So let's go up here, open up our Firefox. And if I go up here and type 192.168.1.6, press enter, this will automatically go and try to connect to the port 80, and indeed it is hosting a web page. But more about this web page later on in the course, as it holds a bunch of vulnerabilities which we will cover. For now, let us just see what other things we got with our Nmap. So besides these known ports that we got right here, we also discovered a bunch of other ports hosting different services, and some of them could be vulnerable. We also see this right here that says not shown 977 closed ports. But wait a second, I said that there are over 65,000 ports. Why does it say that it didn't show only 977 ports? Or it shows that only 977 ports are closed. That is because Nmap by default scans most known 1000 ports. It doesn't scan all 65,000. We can tell it to scan all 65,000, which we will see later on, but in most cases it is not necessary. Okay, cool. Our first Nmap scan gave us some results. And all of these results from our scans, you would write down in a report in a real penetration test. Now that we know how we can scan one IP address, let us see how we can scan a range of IP addresses. Let's say we want to scan our entire network, and for this once again you must know your subnet of your network or your network's IP range. We talked about this earlier. For me it is from 192.168.1.1 up to 192.168.1.255. So we can specify this in two different ways. We can type nmap 192.168.1.1-255, or we can type it like this, 192.168.1.1/24. And if you're new to subnetting, you can think of this /24 as something that says first 3 octets are not changeable. And by first 3 octets I mean first 3 numbers, which leaves us with only last octet or last number that will be changeable inside of our IP range. So let's scan it. If I press enter. Now this scan right here might take a little bit more time, since it is not only scanning one host, it is scanning multiple hosts. And even though it's scanning multiple hosts, it finished relatively fast because it is scanning my own network. Let us read the results. So this right here are the results for the Metasploitable, as we can see by the IP address, and we got the same results as before, which ports are open and what services are they running. Down here we get that it scanned 256 IP addresses and 3 hosts are up. Let's see what other 2 hosts are up besides our Metasploitable. We got a device with the IP address of 192.168.1.4, and it says right here all 1000 scanned ports on this device are closed. And you remember when I told you that this is the more secure version, since right now we cannot connect to any one of these ports. And this is probably some home device, possibly my laptop. It has all 1000 scanned ports closed because it doesn't host any service to other machines. And the last device that we got is my router. We got its IP address and we also got which ports it has open. So it has port 22 for SSH, port 23 for Telnet, port 53 for the domain, port 80 and port 443 for HTTP and HTTPS, and this port right here that says service unknown. This is because Nmap couldn't figure out what service is running on this open port. Okay, great. For now we performed basic Nmap scan without adding any additional options to it. And with this, we managed to discover open ports on our target machines. That is good for the start. In the next video, we will see what else can we discover using Nmap and what other cool options it has.